Hey guys, what's going on? This is Uday from the Vanguard team, and today I've decided to go through Methods Exam 1 2023, okay? Now, I'm a little bit late to the party, okay, I understand that, but hopefully I can provide you guys with a little bit of value in terms of how I approach these exams, okay? So, yeah, without further ado, let's jump straight into it. So, before I even start the exam, let's kind of just walk through the exam. This is what's going through my head during reading time, okay? So, to get started, we can see that there's a derivative question and subbing something into the derivative. Completely fine, honestly. Moving on to question 2, that's just solving an exponential equation. You'll see that we're going to use a quadratic substitution in that situation. And then, question 3, sketch the graph. Okay, so we're just sketching a rectangular hyperbola in part 3a. And then in part 3b, what we're going to do is we're going to be solving for an equation, and we're going to use the graph to help us out. So that should be fine. Okay. Graph 4, use two trapeziums of equal width to approximate the area between the curve. Okay, so we're just going to be using trapezium rule. Once again, I don't think that's anything to stress too much about in this case, so that's fine. Question 5, okay, evaluate an integral, not too hard. Question 5b, hence or otherwise, find all values such that that left integral equals the right integral, okay? And they've given us a little bit of a domain there as well, or an interval for k, okay? That one seems like it'll be a bit of an interesting question, to be honest with you. But I think the way I would probably go about it is just expanding out the right integral, okay, because we'll already have the left integral. And then hopefully that's going to give us some sort of trig equation, most likely, and then we can solve for k, okay? But we'll see what happens when we reach that question, okay? We'll cross that bridge when we reach it. Okay, next thing, okay, so we have a confidence interval question, okay, 95% confidence interval. Okay, they've given us a confidence interval. Find the value of p hat, that's easy, it's just the average. Z equals 2 to approximate the interval, that's completely fine. Okay, find the size of the sample size, find the size of the sample, which is pretty standard as well. And then a larger sample of households is selected, okay. And then they're asking us, well, by what factor do we need to increase the sample size? Okay, that's a very standard question as well, that's fine. Okay, 7, state the range, that's easy. You just look at the y values, okay? Sketch the graph of the inverse function, just reflect it, okay? Part C, determine the equation and the domain, okay? So to determine the equation, in this case we have a quadratic, so we need to convert that into a square root graph. And the way we would go about doing that is probably like completing the square or something along those lines, okay? But like I said, I'll show you how to do it once we reach that question properly, okay? And then calculate the area enclosed by those two graphs. That will be a little bit interesting. You'll see that it's between the two graphs and the line of y equals minus x. We'll have to kind of draw that out to see more so of what's going on. But whenever I see a function and its inverse, I'm always thinking, how can I use symmetry to my advantage? Okay, so there you go. Question 8. Okay, question 8, so we have a continuous probability density function, okay? Show that k is equal to 1 over 64, so the area under the graph has to be 1, that's fine. Find e of t, okay, that's just integrating, basically. What is the probability that someone has to queue for more than 2 minutes given they have already queued for 1 minute? So that's just going to be conditional probability. That should be fine to do. Okay, I heard this question is a little bit algebraically heavy, so you can see me struggle if you really want to, but yeah, conceptually speaking, not too difficult in that sense. Okay, question 9, the shape of two walking tracks are shown below. Okay, so we have track 1 and we have track 2. Okay, this is also the last question, so I'm expecting it to be decently difficult. Track 1 is described by, it's described by a cubic, kind of, you can see there. And track 2 is just defined by a parabola, so that's fine. Okay, given that f of 0 is equal to 12, okay, and f of g of 1 is equal to 9, verify blah, blah, blah. Okay, so you just sub your numbers in and you should be fine, that's fine. Okay, verify that f of x and g of x both have a turning point at p, okay? So they both have a turning point at p. So we're probably gonna have to use some sort of derivative thing. It's completely fine. And give the coordinates of p. Okay, that's also fine. Okay, so that's all all we have to do is we just need to verify that they have a turning point at p. You show that it's the same turning point, and then we'll give the coordinates of it. Okay, part C. This is the very last question. A theme park is planned whose boundaries will form the triangle OAB. OAB, okay? Where O is the origin, okay? A is at K0, okay? And B is at Kg of K, as shown below. And there is a restriction for K. Find the maximum possible area of the theme park in kilometers squared. Okay, so what's happening is we're forming a triangle basically with the vertex of the triangle is lying on track 1, okay? And we're gonna be changing it, and I'll get back to this question a bit more once again. We're gonna be changing it, and we wanna optimize that value of k so that we can maximize that area, maximize the area of the triangle, okay? So actually that doesn't seem too hard on first glance, but you know, we'll see when we reach it, you know? So let's hop right back to the beginning, okay? And get started. Okay, so first question, let y equal to that thing, find and simplify dy dx. Okay, so dy dx, we just need to use quotient rule. So take the derivative of the top, 2x minus 1, okay, multiply it by the denominator, which is that, subtracting, okay, and now we take the derivative of the bottom, which is e to the power of x, and then we multiply it by the top, which is x squared minus x, okay, and divide it by the denominator squared, which would be e to the power of 2x, okay. Now, in these situations, I do prefer to cancel out stuff and simplify my answer. So that's exactly what I'm going to do in this case. So let's just cancel out some of the factors that we have here. So we have 2x minus 1, okay, subtracting x squared minus x, okay, divided by e to the power of x. Okay, so I've simplified the e to the power of x out. And when I do it fully, I will get, let's just be careful here, I would get 3x minus x squared minus 1 over e to the power of x, okay, by quotient rule. Okay, you don't have to write the by quotient rule, but I always like doing it just because it's worth 2 marks, so sometimes it's worth just explaining that working out, okay? But that's what I get when I fully simplify the answer. Is it necessary to fully simplify the answer? Not always, but I like to be on the safer side of things, okay? So there we go, that's the answer in that case. B, let f of x equal to that thing, okay? Let find f prime of pi over 4. So first thing we need to do, obviously, is find f prime of x. So we need to take the derivative. So we would use product rule in this case. So derive the first part, or differentiate the first part, okay? And then differentiate the second part. So that would be 2 sine of x e to the power of 2x, okay? So I've taken the derivative of both of my parts. Now let's sub in that x value, shall we? So when I sub in the x value, I get f prime of pi over 4, which is going to equal to cos of pi over 4, okay, times e to the power of pi over 2, plus, okay, plus 2 sine of pi over 4, okay, plus, multiplied by e to the power of pi over 2, okay. Now that's going to equal to root 2 over 2, e to the power of pi over 2. You can see that I'm kind of expanding this thing out fully because, you know, since it's tech-free, I just want to make sure I avoid any possible algebraic errors, okay? So there we go, we have that, plus 2 sine of that, so it's root 2, okay, times e to the power of pi over 2. And when you sum it up fully, you get 3 root 2 over 2, okay, times e to the power of pi over 2, okay? And that should hopefully be your answer in that case, okay? So there you go. That's that for part B. All right. Part 2, okay? So now we need to solve this kind of equation. Now I told you guys already, this is very reminiscent of a quadratic sort of equation, okay? So what I'm gonna do is we have e to the power of 2x minus 4 e to the power of x minus 12 equaling to 0, okay? Let a equal to e to the power of x, so we do a substitution. And so therefore what we have is we have a squared minus 4a minus 12 equaling to 0, okay? And yeah, let's just factorize that out now. So a minus 8, yeah, sorry, what am I doing? That's not right. A minus 6, a plus 2, there you go. A minus 6, a plus 2 would equal to 0, all right? And yeah, therefore a should equal to 6, or a should equal to minus 2, okay? Now we sub e to the power of x back in. So e to the power of x can equal to 6, or e to the power of x equaling to negative 2. However, it's very important that we reject one of the equations here, okay? Hopefully you guys realize that e to the power of x cannot equal to minus 2. However, okay, so this is what I like to write out. However, e to the power of x is greater than 0 for all real values of x. So we're going to reject e to the power of x equaling to negative 2. Therefore, we get e to the power of x equaling to 6. And finally, x is equal to natural log of 6, okay? And there you go, that's your answer. All right, next question. Sketch the graph of this hyperbola on the axis below, okay? Labeling all asymptotes with their equations and axial intercepts with their coordinates, okay? So I'm gonna highlight all of these parts so that I don't forget to do it, okay? So that's another tip that I have for all of you guys. If you're watching this in the future, just highlight kind of all the requirements of the question. So first things first, whenever I'm dealing with a hyperbola, let's just draw out the asymptotes, okay? Now keep in mind I'm doing this digitally, so I don't really have a ruler on me. If you were drawing out the asymptotes properly though, you would have a ruler, okay? So don't mind me if my asymptotes are terrible, okay? You should use a ruler for it, okay? So x equals 1 is that, okay? And then y equals 2 would be the other one. So there's your x asymptote and there's your horizontal asymptote. So y equals 2. Okay, once again, use a ruler to draw these on an actual exam. Y equals 2. All right, cool. So we have the asymptotes out. Now the next thing we want to do is, well, let's just write down the y-intercept. So f of 0 is just going to be the y-intercept. So that's going to be 2 minus 3 over minus 1, okay? Which is 2 plus 3, which is 5. So 0, 5. There you go. That is your y-intercept, 0, 5. Okay? And so I've labeled all the asymptotes. Now I need to label the x-intercept and the y-intercept. So there's the y-intercept. Let's solve for the x-intercept. So 2 over this thing, so 2 minus that thing has to equal to 0, okay? I take my time when I'm doing this sort of stuff, okay? Because there's no point in trying to rush it, okay? You'll figure out that, you know, solving for the algebra, like normally and doing all the steps is actually relatively fast. Like you see, I found the answer of 5 over 2 pretty quickly, even though I did like the full algebra, okay? So, you know, don't compromise on doing your algebra just for a little bit of speed, because, yeah, contrary to popular belief, writing out all of that working out can actually be much faster, okay? As you can see there, hopefully. So yeah, that's looking all good in that case. And yeah, so I've labeled my two coordinates, my two axial intercepts. Finally, I need to draw in the actual graph, okay? So to do that, what I like to do sometimes is, well, I'll show you what some people commonly do is they just draw the graph like that and they move on. I don't like doing that because personally, you know, your graph could look like that. It could also look something like this, you know what I mean? Like you get a general understanding of the shape, but I want to make sure I don't accidentally lose marks, okay? Or rather, I don't want VCAA to take away my marks from me, okay? These are my hard-earned marks. So instead, what I'm going to do is I'm just going to sub in a few more points. So for example, if I do f of 3, I get 2 minus 3 over 2, okay? Which is going to be 1/2. So I know that another point would be around here, okay? So that means normally what I would have done is I would have drawn it like that, okay? Whereas now I have a little bit more precision because I know it's going to look something more like that, okay? And you can kind of continue that process more and more as you wish, okay? So when you sub in 4, f of 4, you would get 2 minus 3 over 3, so just 1, okay? And yeah, there you go. That's given me more than enough information to kind of draw out the shape of the graph, okay? You could sub in f of 2 as well if you want, and if you do that, you would get minus 1, okay? So there you go. And really, that's more than enough information for me to draw a pretty accurate graph, okay? Just make sure that you don't draw these dots in, okay? And you should be fine. But yeah, there you go. That's the first branch of the graph that we've drawn, okay? The second branch is going to be over here on this side, okay? Oops, on the left side. And once again, I'm going to sub in a few points just to give the examiners an accurate graph, okay? Or in other words, to make sure that the examiners don't take away my marks, because I don't want them to do that. So if I sub in minus 1, I get 2 minus 3 over minus 2, which is just 2 plus 1.5, so 3.5. So minus 1 and 3.5 would be like around here. Okay, if I subbed in minus 2, I would just get 3, okay? And if I subbed in minus 3, I would get 2 minus 3 over minus 4. Now I'm slightly overcomplicating things, so it'd be like around here, okay? But basically, yeah, I have a bit more of an accurate picture of, you know, the graph shape. Once again, your graph should hopefully ideally be neater than what I'm drawing here, okay? Because like I said, I'm doing it digitally, but there you go. That's kind of what your graph would end up looking like, okay? So let's just delete all that. And yeah, I've labeled my asymptotes, I've labeled my axis coordinates. I'm pretty happy with the general shape of the graph. So yeah, that's part A done, okay? So part B, find the values of x for which f of x is below y equals 1, okay? So now we're actually going to be solving an inequality. So really all we're saying here is find when f of x is below y equals 1, below the line of y equals 1. And, you know, if we, below or equal to as well, or equal to. And if you see here, you know, you don't have to draw this graph out, but just to show you guys, you can see that that's the line of y equals 1, okay? So really this entire part of the graph, which I'm kind of coloring in here, that's going to be the corresponding values, if that makes sense, okay? So in that case, I would say that it's below y equals 1 for the values of, okay, from x equals 1 all the way to this point of intersection, okay? So I don't know what that point of intersection is, although I think we found it was 4, so I guess there's another benefit of finding your points earlier, but you can see that it's below or equal to this line from x equals 1 all the way to x equals 4, okay? Why do we not include x equals 1? Well, because x equals 1 is not even defined for f of x, okay? So if x equals 1 is not even defined for f of x, how can we sub it in, okay? How can we sub it in to see if it's below y equals 4? Okay, the answer is you can't, okay? So we don't include x equals 1. So all you're left with is from 1 exclusive to 4 inclusive, okay? And I'll kind of delete all of these brown dashed lines that I'm drawing here. But yeah, that's really all there is to it. So hopefully that kind of makes sense to you guys, okay? Next question, question 4. So the graph of that thing, okay, is shown over part of its domain. Use two trapeziums of equal width to approximate the area between the curve, the x-axis, okay, and the lines x equals 1 and x equals 3. So here's going to be here's our first trapezium, right? Because we're just finding the area below the curve. That's what they're saying, right? So our first trapezium would be like this, okay? It's a really poorly drawn trapezium, but allow it, okay? And our second trapezium would be here, okay, like that, okay? Because we want two trapeziums of equal width, and it's from 1 to 3, so each of them will have a width of 1, okay? So that's fine. Now all we need to do is we need to find the heights of the trapeziums, right? So the area would equal to, so we have y equals x plus 1 over x here. So I'm just going to say let f of x equal to x plus 1 over x, okay? So the first trapezium, we just literally need to use the formula. Hopefully you guys remember that the formula of a trapezium is 1/2 base 1 plus base 2 times height, okay? And that's all that we're really going to use here, okay? So 1/2 times your first base, okay? Your first base is going to be this vertical base, and that's going to be your second base over here, okay? So your first base is just going to be f of 1, and then your second base is going to be f of 2, okay? Times your height, and your height is the width of your trapezium, okay? So that's just gonna be times 1, okay? I'm not even gonna write the times 1 because it doesn't make a difference, okay? But hopefully that makes sense. Plus 1/2 of f2, okay? Because that's this base for your second trapezium. f2 plus f3, okay? Okay, and then you can say times 1 as well, but who cares, right? So there you go, that's that. Now I'm just gonna expand this out and simplify it. So you'll have f of 1 over 2 plus f of 2 over 2 plus f of 2 over 2, so just f of 2, okay? Plus 1/2 of f of 3, so f of 3 over 2, okay? And now our job is just to fully expand that out, okay? So all we have is, we have 1 plus 1 over 1, which is just 1, divided by 2, okay? Plus f of 2, which is just 2 plus 1 over 2, okay? Plus f of 3 divided by 2, so 3 plus 1 over 3, okay? Divided by 2. All right. A little bit of algebra here, but hopefully not too bad. So 2 divided by 2 is 1. Okay, hopefully that makes sense. Plus 2, that's fine. Plus 1/2, that's fine. Plus 3 over 2 plus 1 over 6. Okay, 3 over 2 plus 1 over 6. So I'm going to simplify all of this, and then I'll deal with the 1 over 6, because, yeah, 1 over 6 is a little bit of an ugly duckling in this case, I guess. But anyways, 3 plus 2 plus 1 over 6. So we get, let me just check that I've done my algebra right. 5 plus 1 over 6, which is going to equal to 31 over 6, okay? And the question is just asking for approximate area, so I'll say square units, okay? But it's not necessary to say square units, so don't stress if you didn't do it. I just like doing it personally, but your choice. Okay, there's that one. Let's take a little quick water break before we move on. Okay, I'm being serious. Like during an exam, like make sure that you just take like a few seconds to have a drink of water before moving on. Okay, because water actually refreshes your brain. So after you've done a couple of questions, refresh and get back into it. So question 5, evaluate this thing. Okay, so evaluating sine, I mean, it's simple enough, right? It's just going to equal to cos of x, well, hold on, minus cos of x, right? Always be careful with your negative signs, right? I was about to make a little bit of an error there. Okay, personally, I like getting rid of the negative sign. It just makes the algebra easier, so let's do that. Okay, which is going to equal to cos of 0, okay, minus cos of pi over 3. All right, which is going to equal to 1 minus 1/2, which is just 1/2. Okay, simple enough. There you go. Okay, hence or otherwise, find the value, all values of k, such that this thing is equal to that thing. Okay, the two integrals are equal to each other for this integral. So how are we going to actually find this? Well, we already found the left integral in the question above, so that's always nice. Let's find this right integral in terms of k. So k pi over 2 cos of x. Okay, that's what they're saying. Yep, cos of x dx is going to equal to sine of x, all right, pi over 2, and then k, and then we just sub those in, right? So sine of pi over 2, minus sine of k, okay, cool. And we know that that has to equal to 1/2, all right? So fair enough. Okay, therefore, now let's simplify this out a little bit, shall we? So sine of pi over 2 is just 1. 1 minus sine of k has to equal to 1/2. And so therefore, sine of k has to equal to 1/2. Okay, there's your trig equation. All right, so far so good, hopefully. And now, the final part that we need to do is just, we need to solve this over this domain. So we're literally just solving a trig equation now, right? Just a regular trig equation, except, yeah, k has to be between minus 3 pi and 2 pi. Okay, so what are the two base values in this case? So base values is kind of, whatever, it's a term I use, but you know, there's two quadrants here. It would be this one and that one, because sine is positive. And we know that it would either be pi over 6 or 5 pi over 6. Those are your two base values. And then we can add or subtract periods accordingly, okay? So, therefore, k can equal to pi over 6, 5 pi over 6, okay? So, those guys work, all right? And yeah, we can try adding and subtracting periods, okay? Now, if I added a period, so keep in mind the period I'm referring to is sine of k, and the period in this case would be 2 pi. If I added 2 pi, you can automatically see that it's not going to fit in this domain because there's an upper restriction of 2 pi. So if I had pi over 6 plus 2 pi, it wouldn't work, right? So obviously I can't add a period in this case. And same thing for 5 pi over 6. I can't add a period. It'll be outside of this interval. How about I subtract a period? Okay. If I subtract a period, what actually ends up happening is I'll have, let's see here. I'll have pi over 6 minus 2 pi. Okay, that's the first one. And then I'll have 5 pi over 6 minus 2 pi. Okay, there's a second one. Okay, and that should fit within this interval. Okay, but I can't subtract another period, so I can't do pi over 6 minus 4 pi, because that's gonna be below minus 3 pi. Okay, I can kind of just do that in my head. Okay, if you can't do that in your head, just work it out yourself and you'll realize it. Okay, nothing wrong with that. So, yeah, hence or otherwise find all values of k. That's fine. So really all I need to do now is just simplify. So k equals pi over 6, or k is equal to 5 pi over 6, or k is equal to minus 11 pi over 6. Okay, we keep on keeping on, and or k is equal to minus 7 pi over 6. There you go. Cool. Minus 7 pi over 6. Nice. So yeah, that is looking right. I just always like to take a look at my answers to make sure if it grammatically, make sure that it just makes sense numerically, not grammatically. What am I saying? Too many letters in maths nowadays, right? Yeah, that's fine. That looks fine to me. Yeah, so those are your 4 solutions. Find all values. That's fine. Okay, let's move on to question 6. Okay, so yeah, like I said, we have a confidence interval, which is given here. P hat remember p hat is just the middle value of your confidence interval. So it's just going to be 0.04 plus 0.16 divided by 2, which is going to be 0.10 or 1 over 10, okay? I always like to give exact values because it is exam 1, okay? Let me make sure this looks like a 10. There we go. 1 over 10. Okay, so that's the value of p hat. Use z equals 2 to approximate the confidence interval. Find the size of the sample from which this confidence interval was obtained. So for me, I don't really care about the confidence interval itself. I actually care about the margin of error, okay? So the margin of error in this case is going to be equal to 0.16 minus 0.10. So that's the p hat value that we got earlier, which is going to equal to 0.06, okay? Now, what I'm going to do now is I'm going to sub that into kind of the formula that we have, all right? So that's all good. So yeah, like I said, I'm going to sub that into the formula. So the formula for margin of error, hopefully you guys remember, is equal to kind of like the z value, okay, which they've given to us, thankfully, times p hat, 1 minus p hat divided by n, okay? Now, n is the thing that we're solving for, okay, so keep that in mind. Anyways, we have the value of z, which is 2, okay, so we approximated that, times p hat, so p hat is 1 over 10. This is where I say that using a fraction is easier than using the decimal, times 9 over 10, okay, divided by n. Okay, so far so good, which is going to equal to 0.06. Once again, I'm going to simplify that out into a fraction. So 6 over 100, or in other words, 3 over 50. Okay, let's simplify this out now, finally. So we have, first of all, I'm going to take this 2 to the other side, so I get 3 over 100. Okay, 3 over 100. And then we have 9, okay, 100n, like so. Okay, and yeah, all we need to do now is just need to solve this, okay? So I just want to make sure I have enough room to do that. So if I kind of simplify out the left side now, okay, I should get 3 over 10 times, 1 over root n. I know it's looking a little bit funky, but, stick with me. 3 over 100, okay? Now all I need to do is I just need to cancel out my sides. So therefore, root of 1 over n is going to equal to, so that's 1. It's going to equal to 1 over 10, okay? Which means that, therefore, kind of just looking at it, n would have to equal to 100, okay? N would equal to 100. So that would be your sample size in this case. Okay, so a larger sample of households is selected with the sample size 4 times the original sample. Okay, cool. So the sample's proportion of households is found to be the same. Okay, so p hat is the same as what they're saying here, but what we've done is we've increased the sample size from 100 to basically 400, okay? By what factor will the increased sample size affect the width of the confidence interval? Okay, so all we're asking ourselves in this case is, well, by what factor, if I'm increasing the sample size, how am I going to change the width of the confidence interval, okay? Now you can do this mathematically, or you can kind of just think about it conceptually, right? Like imagine I have my confidence interval, right? My original confidence interval, let's just say the width. Okay, I'm just making some random stuff up here kind of, but, right? Let's imagine it's 1 over n, okay? My new width is going to be 1 over 4n, okay? Because I've quadrupled my sample size, which is going to equal to 1/2, okay? Because I'm taking the 4 out now. 1/2 of root of 1 over n. So all I've done is I have my original width over here, okay? I'll just call it the OG, okay? There's my OG width, and I've multiplied that by 1/2, okay? So literally, if I increase my sample size by a factor of 4, I've essentially halved my sample size. Okay, I've halved my sample size. Okay, which means that by what factor have I done it? It's basically like decreased by a factor of 1/2, if that's how you want to voice it. Okay, decreased by a factor of 1/2. Or increased by a factor, yeah, decreased by a factor of 1/2. As long as you specify that you've halved the sample size, you should be fine in this case, okay? So, because then they'll understand what you're talking about, okay? By what factor will the increased sample size affect the width? Well, you've kind of halved it, right? So it's a bit weird whether you'd say you've increased by a factor of 1/2 or decreased by a factor of 2, if that makes sense. It's getting into kind of semantics now, okay? But you'll realize that the VCAA examiners are pretty forgiving in that sense. So as long as you specify that it would be halved, so the width would be halved, width of confidence interval halved by sample size. Okay, and as long as you use some proper English, to be honest, you should be fine in this case. Okay, but yeah, there you go. Your width of the confidence interval would be halved. So, next question, state the range of this thing. So, first of all, let's take a look at the domain. So, the domain, it stretches to negative infinity, so it'll keep on going on and on and on, but it stops at x equals 1. Okay, so state the range of f. Range of f, like I said earlier, it's just the y values. So it's going to be from negative 1, because that's the lowest y value, as you can see here, negative 1 all the way to infinity, basically. Okay, because it's going to keep on stretching on and onwards. So there you go, that's your range. Cool. Sketch the graph of the inverse function, labeling endpoints and axial intercepts. Okay, so the inverse function, as you guys know, it's just going to be the reflection in the line of y equals x. So I'm just going to draw the line of y equals x in this case. As I always say, use a ruler. I don't have one, okay? But yeah, there you go. And then let's just, all we have to do now is just reflect, right? So we know that the graph is going to cross through this point over here at 0, 0. I should probably use black, right? You guys don't have brown pens. 0, 0. Okay. We can see on the original graph there was the point of, the point of 1 minus 1. So we're going to flip that and we're going to get minus 1, 1, okay? And that's going to be the endpoint in this case, okay? That's going to be the endpoint. And now our graph is just going to kind of keep on stretching onwards. You can see here that there's also the point of minus 1, 3 on the original graph. So we're probably going to go to around 3 minus 1, okay? 3 minus 1. I don't know if that's the exact point. Let me just check. Minus 1 squared is 1 plus 2. Yeah, so minus 1, 3 was an original point. So 3 minus 1 would be another point. So like I said, guys, I like to just put some extra points on the graph so that I have an accurate shape, okay? So this is going to be a little bit ugly on the digital side of things, but yeah, okay, there you go. You know what, that's good enough. So there you go, that's my graph. I've labeled the endpoint of minus 1, 1. There's my axis intercept of 0, 0. I'll just label it as y equals that as well for simplicity, okay? And that's looking fine to me, okay? Label any, yeah, so I labeled endpoints and I labeled the axis intercepts with the coordinates. Okay, and I sketched the graph in general. So that's good. Okay, so determine the equation and the domain for the inverse function. Okay, so determining the equation, now like I said earlier, we have let y equaling to f of x, which was x squared minus 2x, as you guys remember. Yep. So the idea is that if I swapped x and y, I would end up getting this thing. Okay, I would end up getting that thing, and it's just really weird to solve for this, okay, unless you do like some sort of completing the square thing. So what we're going to do is we're going to complete the square first. So therefore, y is going to equal to x minus 1 squared, because that's going to be x squared minus 2x plus 1. Okay, and then we're just going to subtract 1. Easy. Okay, so y is equal to x squared, x minus 1 squared minus 1. Simple enough, okay? And now what I'm going to do is I'm going to swap x and y. Okay, so swap or interchange x and y. Okay, so therefore, x is equal to y minus 1 squared minus 1. Therefore, y minus 1 squared is equal to x plus 1. Okay, and therefore, y minus 1 is equal to plus minus root of x plus 1. Okay, and therefore, y is equal to 1 plus minus root of x plus 1. Okay, which makes sense, right? Which makes sense because we have our endpoint at minus 1, 1. Okay, problem is we have two branches, right? We have this plus minus. So which branch do we pick? Well, we do have to reject one, and that's actually a very important part in your working out. You must reject one. So in this case, I would reject the positive branch. I mean, if you just look at the graph, you can kind of see that. Reject the positive branch, okay? And you can use whatever reasons you really want here. You could just say, you know, looking at the graph above. You could also say because, range of your inverse function has to equal to the domain of your original function, which has to be from negative infinity to, 1 inclusive, okay? So because it includes the negative infinity, it has to be the negative branch, because only the negative branch will stretch to negative infinity. Okay, so there's my reason. That's a pretty solid reason. So therefore, we know that the equation of my inverse function is going to be this thing, okay? So inverse of f equaling to 1 minus root of x plus 1, okay? There you go. That's the first part. That's the equation. But we also need to give the domain, okay? And that's not going to be too hard. The domain of the inverse function is just going to equal to the range of my original function. And we already found that the range of the original function was minus 1 to infinity. So we've got our work cut out for us. So minus 1 to infinity. That, or you can just look at the graph above once again, okay? But in case you messed up your graph for whatever reason, or if you weren't confident in it, that's just kind of how you can also figure it out, okay? So there you go. That's the equation and the domain for the inverse function, okay? Make sure that you write your inverse function as like this and not like y equals this, okay? If you wrote it as y equaling to the square root function, you're not going to get the mark, okay? Because, yeah, VCA specified that they need it in this form with that symbol, okay? They've taken off marks for that time and time again. So, yeah, make sure that you write that inverse of f. And the final part of this question is calculate the area of the regions enclosed by all of these graphs, okay? So, y equals minus x, you know, you can kind of just sketch this on this. I'll try to sketch it. It would look something like that-ish. Okay, kind of like that. Can I rotate this? Hold on. Oops, not that. Rotate on, there you go. Okay, now I can rotate stuff, great. So you can see that's kind of the line of y equals minus x, okay? Now, as I told you guys earlier, whenever you're dealing with inverse functions, you always want to think about symmetry, okay? Particularly because they're symmetrical along the line of y equals x. Everyone knows that pretty much. But in some cases, okay, in some cases they're also symmetrical around the line of y equals minus x. And you can kind of see that, well, you can kind of see that in this case, right? Like this area over here to the left is going to equal to this area to the right, okay? Which is going to actually help us out a lot when it comes to solving this integral, okay? Because I don't actually need to write out two separate integrals in this case. All I need is one integral, okay? So what would that one integral actually be? Well, all I'm going to do is I'm going to say the area is going to be, you know, the integral, okay? And I prefer integrating a parabola. I think it's easier than integrating a square root function. So we have y equals minus x on top, okay? That would be y equals minus x there. So we have minus x, okay? That's the top line. Subtracting the parabola, so subtracting x squared minus 2x. So that'd be x squared plus 2x, because there's a double negative there, dx, okay? From what domain? Well, from 0 to 1, as you can kind of see there, okay? From 0 to 1, but I'm going to double that area, okay? Because the area on the left, or this area on top, whatever you want to call it as, this area here is going to equal to that area over there, okay? So I'm going to double that. So, with that in mind, let's kind of write this integral out, shall we? So, actually, I'm going to simplify it a little bit. Okay, so this is just from 0 to 1. So we'll have x minus x squared, basically, dx. Yep, that looks good. So, let's write it out now. So, that's going to equal to 2 times, okay, so x squared over 2 minus x cubed over 3. Yes, sir. Okay, sorry, I don't know why I did that. Yep, there you go. Equaling to 2 times 1/2 minus 1/3, okay, which is going to equal to 1 minus 2 over 3, which is equal to 1/3 square units, okay? And yeah, that's pretty simple, okay? That is pretty simple. So not even that much working out involved in this case, okay? If you wanted to really check your answer, something you could do, like after you've gone through the exam once, is you could try integrating the left side, okay, and see if you get the same answer, okay? Hopefully you would, okay? Question 8, second last question, and this was the one with the crazy algebra. So, show that k is equal to 1 over 64. This one's not too terrible, it's just, like I said, so from 0 to 4, k times t of, I'll just expand it out, 16t minus t cubed, okay, dt, should equal to 1, okay? It should equal to 1, okay? Therefore, k, and now what we need to do is we need to integrate. So 8t squared, okay, minus t to the power of 4 divided by 4, yep, 4, 0 equaling to 1, okay, so that's fine so far. Okay, therefore k is going to equal to, sorry, not k is equal to, what am I saying? K times 8 times 4 squared, okay, so 8 times 16, 8 times 16, which off the top of my head is 8 times 8 times 2, so that's going to be 128, that's fine, minus t to the power of 4 divided by 4, so 4 to the power of 3, which is 64, okay, equaling to 1, therefore 64k is equal to 1, therefore k is equal to 1 over 64 as required. Simple enough, okay, simple enough, there you go. So, now we need to find e of t, so now we need to do more algebraic nonsense to find the answer. So, e of t, as you guys hopefully know, is just going to be, so we're taking it from 0 to 4, okay, it's going to be t times f of t, okay, that's how you calculate it out. So that's going to give us, I'll just write 1 over 64 in the front and take it out already. Okay, so t times, so t times that thing, so 16t squared. Okay, I have to be very careful here. Minus t to the power of 4, I think. Okay, let me just be very careful here. So I have 16t minus t cubed. I'm always prone to making algebraic errors in these cases, so I just want to be extra careful that I haven't stuffed something up. So I multiply that by t, yeah, that looks right to me, and then we have 1 over 64, which is in front, okay? And yeah, now all we need to do is we just need to expand it out, okay? So yeah, this algebra is already looking like it's going to be painful, but you know, it is what it is. We keep on keeping on. I need to stop saying that, but anyways. T to the power 5 over 5, okay? 4, 0. I mean, it could be worse, right? It could be worse. Thankfully, like, we have 0 at the bottom, so that's our saving grace. But yeah, we have 1 over 64. So 16 over 3 times t to the power of 4, which is 64. Nice. Minus t to the power of 5, which is like, I think it's 1024, if I'm not mistaken. That's t squared, so 16 times 16 times 4, okay, over 5, okay, subtracting 0, basically, subtracting 0, that's all I'm going to do, okay, and that's going to equal 2, and now what we're going to do is we're just going to cancel stuff out, so we get 16 over 3, okay, minus 16 over 5, okay, so that's kind of the easy way to sort of circumvent some of that algebra. So you get 80 minus 48, yes sir, over 15, and you stop saying yes sir, but it's fine, 32 over 15. Okay, 32 over 15, and that would be your average value, or expected value. Okay, what is the probability that a person has to queue for more than 2 minutes, given they've already queued for 1 minute? So, probability that t has to be greater, probability that t is going to be greater than 2, given that t is greater than 1, okay? We don't have to worry about whether it's inclusive or exclusive, okay? And you can see that the variable is t, so that's completely fine. And t is in terms of minutes, so that's also completely fine. So, yeah, expanding that out is just t is greater than 2, and then probability that t is greater than 1, okay? That's all good. And yeah, that's gonna equal to, it's gonna equal to a bunch of garbage, okay, from what I've seen. Yeah, so from 2 to 4 of f of t, dt, and then 1 to 4 for f of t dt. Okay, and now we can experience the full pain of integration. So in the numerator, all right, in the numerator, so we've already kind of found the full integral there, kind of. Okay, so 1 over 64, Okay. So what I'm actually going to do is I'm going to kind of take out the 164 from the front. Okay, so let me write out the full thing so that you guys don't get confused with what I'm doing. Okay, so the first thing that we have is from 2 to 4 for f of t. So f of t is equal to 16 t minus, t cubed. That's what we found earlier. Okay, I'm just dragging it down. 16t minus t cubed dt. Okay, and remember there's a 1 over 64 at the front. I'm going to bring that out. Okay, and I'm going to do the same thing with the bottom part. So 1, 4, okay? 16t minus t cubed dt, okay? I'm just trying to show you guys maybe how I would do it to try and reduce the burden of algebra. So automatically I can cancel those out, okay? So I don't have to worry about the 1 over 64 anymore. So hopefully you guys did that when you were solving it. What else could you do? So now all you have to do is just expand it out and yeah, pray for the best. So what I'm gonna do now is I'm gonna expand it out, like I said. So we already found the integrated form earlier, right? So 8t squared minus t to the power 4 over 4. So you can save yourself a little bit of brain power there. 8t squared minus t to the power 4 over 4. Not that it's that hard, but you know, it is what it is. And then, yeah, I'm gonna copy this thing, and then same thing, oops, okay, copy, there you go, 1, sick. And now all we're gonna do is gonna sub it in and let it do its magic, you know? So when we sub in 4, I think we found it earlier, right? When you subbed in 4. So when you subbed in 4, all you get is 64, okay? As we found up here. So you should only get 64 for the first number, right? This is why I like referring to earlier parts of the question, because sometimes they give you tiny hints or tiny just useful pieces of information, right? So I don't need to find it out again, but I guess if you did, you know, it'd be 8 times 16 minus 4 to the power 3, which was whatever it was again, 64, blah, 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 wasting my life, it's fine, okay? Wasting my life doing algebra, but hey, it's fun, right? It's calm. So yeah. I'm just thinking about whether I did that right. 80 plus 48. I'm like questioning life right now, basically. But yeah, no, 64 is right. Okay, so 64 is right. So 64 subtracting, anyways, yeah, I'm having a mental breakdown from algebra. No, I'm not having a mental breakdown. That's fine. Subbing in 2 now, so you get 8 times 2 squared. So that would be 8 times 4, which is 32. Okay, minus 2 to the power of 4. Okay, 2 to the power of 4 divided by 4, so that's gonna be 2 to the power of 2, right? So that's 4. Did I do that right? 16 divided by 4. That makes sense. Makes sense. Yeah, that's fine. Okay, take your time when you're doing this algebra, by the way, guys. I'm just doing it quickly because why not? 8 minus 1 over 4. Okay, that's a little bit annoying that we have a fraction down there, but it is what it is. 64 minus 28. Okay, so there's the first part. Divided by, okay, 56 plus 1 over 4. Okay, 56 plus 1 over 4. And so 64 minus 28, we can say, I can add 6, so that's 36, okay? And then that's divided by 56 plus 1 over 4. So 56 plus 1 over 4, 56 times 4, okay? Yeah, I know, like this is literally how I'm doing it, just to be safe, right? Should be 200. Does it make sense? No, it doesn't make sense. 224, yeah, makes sense. Okay, 224 plus 1 over 4. Okay, so it'd be 225 over 4. Okay, 225 over 4. Okay, nice. Okay, and that's going to equal to 4 times 36, which is 144 over 225. Okay. And I don't think you can simplify that further because, yeah, I don't think you can. So 144 over 225, okay? There you go. And that's most likely how you would solve it, okay? So really my best tip there is just, you know, try and see if you can use previous values and sub it into the question. And the next thing is just don't panic, take your time, and you'll reach the final answer eventually. It's not too hard, okay? And yeah, let's move on to the final question, okay? So we're reaching the end here. Track 1 is defined by this function, nice. Track 2 is defined by that function, okay, that's all good. Unit of length is in kilometers, okay, sure. So f of 0 has to equal to 12, okay, so therefore a minus, 0 is going to equal to 12, so a has to equal to 12, simple enough. And g of 1 has to equal to 9. So when I sub in x equals 1, I get 12 plus b equaling to 9, therefore b is equal to minus 3, okay? And then I just say as required. Simple enough, okay? Great. So now, verify that f of x and g of x both have a turning point at P. Give the coordinates of P. So both f and g need to have a turning point at P. So what we're gonna do is we're gonna just do a little derivative kind of thing, okay? So what I'm gonna say is, we already have f of x equaling to, I'm going to write it up here, f of x is equal to 12 minus x times x minus 2 squared. Okay, x times x minus 2 squared. I'm gonna, well, you can expand that out. What I'm gonna do is I'm just gonna take the derivative of it. So that's fine, that'll just be gone because it's a constant. So I'm doing product rule here, which is a little bit dangerous, but it is what it is, right? It is what it is. I'll take the derivative of the first part, so it's minus x minus 2 squared, and then I'll take the derivative of the second part and bring that down. So minus 2x, x minus 2. Okay, simple enough. And yeah, now I just want to solve f prime of x equaling to 0, and you can kind of see here that you can factor out x minus 2, it's a common factor. So x equals 2 would be kind of your solution in that case, okay? I know it's a little bit of a risque strategy, okay? But we also have g of x that we need to deal with. So hopefully we'll see if g of x gives us the same answer. So g of x, TP for g of x. Now because g of x is a parabola, it's going to occur at x equals minus b over 2a. So minus b, so minus 12. Okay, so the coefficient of that, coefficient of x, minus 12 over 2 times minus 3. 2 times minus 3, which is minus 12 over minus 6, which is equal to 2. And yeah, look at that. So they both share a turning point at x equals 2. Thus, both graphs share a turning point, a TP, at x equals 2, okay, at p. And now all we need to do is we just need to find the coordinates of p, okay? So simple enough, I'm just going to sub in x equals 2 into one of these equations. It'll be easiest if I sub it into f, actually. So f of 2 is just going to equal to 12 minus x times 0, okay? So 2 times 0 squared, basically. Okay, because you can see that has x minus 2 squared there. Okay, so that's just equal to 12, so therefore the coordinates of it should just be 2, 12. Okay, that should be fine. 2, 12. Great. And yeah, let me bring this question up. So 2, 12, is that fine? Let's see. I'll check the other one just to be careful. G of 2 would equal to 24 minus 3 times 2 squared, which would also give you 12. So yeah, I'm pretty confident with that one. Okay, so a theme park is planned whose boundaries will form this triangle where O is the origin, A is at this point, and B is at this point. Okay, and K can be between 0 and 4. Find the maximum possible area of the theme park. So first things first, I need to find an expression for this triangular area. So I need to find an expression for the triangular area. I have been recording, right? Surely. Yeah, I am recording. Okay, sorry. I have to be careful with these things, man. I've recorded stuff before and it hasn't recorded. Anyways, area AOB, okay, I'll just say area, is going to equal to, it's a triangle. Okay, so it's 1/2 times your base times your height. Times base times height. Now the question is, what's your base? Well, if you take a look at the different triangles that you can draw, I'm just drawing up some random examples here. But you can see that the base is going to be K, okay? Because remember, this is at the point of K and then G of K. Okay, K and G of K. G of K. So your base is going to be at K. So 1/2 times K times G of K. So that's literally your triangular area. So 1/2 times K times G of K. Okay, which is going to equal to, well, 1/2, so K over 2. And then we need to sub in K into G of X. So remember that G of X was equal to 12x minus 3x squared. Okay, so just sub in x equals k into that. So we'll get 12k minus 3k squared. Okay, minus 3k squared, which is going to give us 12k squared, so 6k squared, minus 3 over 2k cubed. Okay, great. So therefore a is equal to that. So now we want to find when it's the maximum. So, as per usual, we're just going to sub it in. So, sorry, we're going to take the derivative and then we're going to solve for when it's equal to 0. So that's going to give us 12k, okay, minus 9k squared over 2, okay? And now I want a derivative to equal to 0, so k has to be between, 12 and minus 9 over 2k equal to 0. Okay, boom, therefore k equal to 0 or 9 over 2k equals to 12. Okay, it's just solving algebra now. So k can equal to 24 over 9, which is, if I divide by 3, 8 over 3. Okay, so now we need to pick a solution. Now, obviously, you can kind of reject k equals 0. Okay, reject k equals 0 because as k has to be between 0 and 4, and I think it's exclusive for both sides. So therefore, the value of k would be 8 over 3. Okay, that's the value of k. Now, do they want the maximum possible area as well? Yes, they don't even care about k, they just want the maximum possible area. So, okay, so we found k equals 8 over 3. So now let's sub that into the area formula to get our final answer. Okay, so area of 8 over 3, so we're just gonna sub it in. So we have 6 times k squared, so 6 times 8 over 3 squared, so 64 over 9, subtracting 3 over 2 times k cubed. So 8 cubed is 8 times, so 64 times 8 basically, which is 480 plus 32, so 512, divided by, 3 cubed, which is 27. Okay, cool stuff. So we can simplify this out as well. So you get 128 over 3, subtracting, okay, so that gives us 9, and then that gives us 256. So subtracting 256 over 9, okay? So we can multiply that by 3 now. So we have 3 times 128. So divide by 9 everything. 3 times 128, which is 256 plus 128, if you think about it. So 256 plus 128, okay? Subtracting by 256, these guys will cancel out, and that's going to give you 128 over 9, okay? Square units, or what units did they say? They said kilometers squared. So 128 over 9 kilometers squared, okay? And that would be your final answer, okay? So yeah, and with that being said, that's the end of this entire exam. So I really hope that you guys found all of that really helpful, okay? Hopefully. But yeah, make sure that you guys like, subscribe, comment down below if maybe I did anything wrong, or if you want me to record anything else for methods. But yeah, until next time, guys, have fun.